Okay, everybody. How are you? If you could type into the chat just to say, do you hear me right now? I see I have six people out of 10. If you if you have your screen, if you have your camera on, which you don't need to, but if you want to put a thumbs up just to see that I am being heard, I see the one person I see is Letitia, and I do see a thumb up, which I appreciate. Um, Also, can we see the iPad? It has like a strange set of N643. Do you see that also? Is what's up on the screen? Is there iPad on the screen? Oh, and let me see where the chat is. Hold on. Oh, okay, the iPad's not on the screen anymore. Let me take a look here. Where did it go? Oh, here we go. Another person coming in. And let me just get my iPad. Oh, I see. Okay. So my question now is, you can type into the chat. Is the iPad? Do you see N643? Is that up on the screen right now? There we go. Is the chat good? Okay. Uh, I'll put my camera on for a second just so you can see me. So this is me. I'm Gary Rubenstein. This course is called History of Math, and I've been teaching this course at City College over the summers, I would say for about 10 years. Some years they offer it, some years they don't, but first time I did it was about 10 years ago. Now I'm going to go back to the iPad and tell you about what we could expect here. So if you can go on your browser to student.desmos.com and you type in this code N643BF, I'll show you what that. So I think I can give you a link to that. Let me see if I'm able to.
It says the code is not working. Is that a B or an 8?
Oh, that's a B, and I'm going to put let me put an actual link in here so that here you go. If you try it this way, see if that works. Now, what this will do is it will bring up a Desmos activity. So, we have this remote class most of the days, and of course, it's not as fun as a regular class where you're like sitting next to actual people and you get to talk to them, and just there's an energy about that. The only good thing about, in my mind, about remote, well, there's two good things. One is that there's no commute. But the other one is that if this were a large class and I wanted to really double check, is everybody getting the concepts, or is anybody just kind of like nodding their head but not really following along? Well, I could just ask questions on this, and everyone has to sort of type in their answers. So throughout each of these classes that we do remotely, you'll also have this Desmos activity up, and you'll answer questions on there, and that's how I'll keep track of like if people are understanding and following along. Um, like already, there's a question there, question one, just to write like a little bit about yourself, just as a first day sort of thing. Some people are grad students, some people are teachers. I'm actually I'm a high school teacher, and I just do this during the summer. Some people are middle school teachers, some people are high school teachers, some people are grad students, some people maybe are just taking the course, they're math majors, a whole bunch of different groups of people. I'm just kind of curious. And this question will get sort of shared with the class. So whatever you type, the other people are going to see it also. So don't write anything that's sort of the sort of private information. So you could type in a little something there, and everyone can see what everyone else wrote. So go ahead and do that for a moment. And I'm going to take a look. Okay, and as you can see, uh, we have Leticia, 21 years, Department of Ed, just like me, 21 years at the Department of Ed, and departmental math teacher, math chair. Well, that's very cool, Leticia or Letitia. How do I say it properly?
Letitia.
Leticia. That's great that you're a department chair because a lot of this math uh, is it's not that it's hard math, it's just more like clever and interesting. So this math can actually be incorporated into high school, middle school, elementary school teaching also. So if you're department chair and the more you know about this kind of stuff, you can help your teachers use it if it's appropriate for them. Okay. Now we have Kelsey is a fourth grade teacher and a grad student, master's degree elementary math specialist. And for elementary school, a lot of this math, what's funny about it is, as you'll see today, um, it's going to make you feel like your students sometimes feel. Like the math itself isn't going to be, it's not that it's so hard, but it's unfamiliar. And it's like once you understand it, it seems easy. But before that, it's like it's you kind of you get an opportunity to feel what it feels like to be elementary school students sometimes as you're doing this, because some of the math is so basic, but it's in an unfamiliar to you, and you get like an opportunity to say, oh, what does it feel like to add for the first time? You get to relive that. And here we have Michelle is a sixth grade teacher, IS 181, better foundation in math. Yes. Janet is a elementary teacher, improving math teaching. And this is great, the micro credential. Stephen, graduate with a bachelor's in criminal justice, started substitute teaching, went back to school, a master's in math education. And then we also have grad student working towards. So everyone here is some sort of a school teacher or working in a school also. Sometimes there's people who are just pure math majors. Um, the good news is for anybody, the math in this course um, is mainly a lot of adding and subtracting, multiplying, dividing, uh, some basic geometry. But for instance, there's no trigonometry. Like there's nothing if you say, well, I kind of forgot some of the math because I'm teaching elementary school and algebra is about as far as I can really feel confident with. None of the math requires anything more than that. But that's not to say it's going to be easy because you could actually do there's a lot of confusing things that can happen with math, with this history of math. So I'm going to get started with the first of the cultures. Oh, and you know what? Maybe I should have you. This will be fun just to type into the chat. What do you, if someone said, okay, what do you know about the history of math just already? Just throughout your life, somehow you've picked up a little bit of history of math. Maybe a teacher told you something when you were in school, or maybe you're a teacher now and you were looking at the textbook, or maybe you researched it because you were wondering who invented this or who invented that. You want to type into the chat itself, just the Zoom chat. What are some things what do you already know about history of math just because you picked it up? Maybe it's names of mathematicians or theorems that you feel like were invented in different countries. Go ahead, type some stuff in. I haven't seen anything yet. So if you want to type in the name of a famous mathematician or a country that you feel like a lot of math was was maybe invented in? Oh yeah, what did Malcolm Gladwell say about did he talk about history and math? I did once see him write something about how like in different countries their number systems had helped them, just the nature of their number systems and the words they used made math easier for like children to understand. Is
Yeah,
that
that's what I was trying to type and I hit enter by accident. But yeah, like in a lot of Asian languages, it's like the number system's already in base 10, which makes
Mhm.
it's I guess they have an innate understanding of like, like it's 10 and 1 would be 11 as opposed to, or like 10 and 2 would be 12 or something like that, you know?
Yes, yes. That's right. So just by sort of an accident of how someone's language developed, uh, could could make uh, that culture, their children be able to learn math somewhat easier because of the notation. Actually, throughout history, um, notation got simpler and simpler, and it really helped people understand math. Some things that were fairly easy that are easy to us now, uh, before they invented nice symbolism, seemed like really, really complicated. Hmm. Okay, so we're looking through the different comments, and it's about a Mayan base and math fluency visible, learning the math is universal. Yeah, that's, ooh, no, did I lose my iPad? Hold on. Sorry. I need to reconfigure my iPad. This will only take a second. Just have to type something in here. 329110700. There we go. Okay, let's hope the iPad pops up again. Okay, I'm looking through some more comments. So not that many people wrote anything, but I do appreciate those people who did. Well, in this course, we're going to study math ranging from the year 1800 BCE all the way through about 1800 Common Era. So that's 3,600 years of math. That's a lot of math to do in 15 classes. Of course, there's a final exam on the 16th class. Um, so I had to pick and choose, obviously. And the cultures that we're going to study are Babylonian. We do that for about 3 class periods. Egypt, we do for about 3 class periods. China, we do for about 3 class periods. Greece, we end up doing for also 3 or 4. Greece gets an extra one, and then we end with sort of European. For a long time, before a lot of these, for a long time, people gave European mathematicians way too much, Greece and European, like all the credit for inventing all the math. Um, but in the last maybe 100 years, they found so many ancient artifacts from other countries and got interested in these other countries. And now we know that they wouldn't be Greek in Europe. Europe, obviously, Greece is in Europe, but they wouldn't be Greek and they wouldn't be math in France and England and all had they not built upon the math that was invented in these other countries. And who knows, there could be countries even before them that the Babylonians learned from, but we don't have records of those. So the earliest we go back is around 1800 BC, which is too bad. There might have been artifacts way before because the Babylonian math is already fairly sophisticated. So there must have been something they built on before that, but we don't really know what that is because it's lost. Babylonians had these clay tablets that survives for all these thousands of years. The Egyptians had this papyrus that also survived for thousands of years. So we some of the stuff we just don't have, and we'll never know. Who do the Babylonians learn their math from? Okay, I'm going to get started now. So that was a little introduction of what to expect. The very first question is a riddle for you, and actually I have in the that Desmos activity. If you go to the second slide, and I am going to come over here. Why don't I bring up the slide also? Just say continue without signing in. It's fine. That's me. So we did this first question. But how about this? Oh no, that's not what I wanted to do is the second question. So ignore that. Instead, let me write this down. This will be one that we could type into the chat. Here's a riddle for you. 159 plus 1 equals 2, 0, 0. Well, everyone knows 159 plus 1 is 160. But under what circumstances is this correct? You could type it into the chat just for fun. You could even unmute and just say it if you want. So it's a little riddle. Any ideas about under what, in what world, in what scenario, under what conditions could this actually be a true mathematical statement? Anyone want to take a fun guess? Again, there's not, Okay, if you need $200, well, it would be good if the 159, if you can get one more, you would have 200. But how? And I don't want to give a hint just yet, but all I'll say is every single day of your life, you encounter this situation twice a day where it seems that 159 plus 1 becomes 200. That's my hint for you. By the way, I'm recording. I hope I'm trying to record all these lessons. I clicked a button that they changed Zoom a little bit, so I don't see that it is recording, but I think I'm recording. And yes, it does have to do with time, because when it's 1:59 and you add 1 minute, the next minute after 1:59 is 2 o'clock. And that's because our time system is in what's called base 60. We have a base 10 number system in our regular, what we call, our math now. But the Babylonians had a base 60 system. And I'll explain a little bit about what that means. But of course, there's 60 seconds in a minute and 60 minutes in an hour. There's not 60 hours in a day, though. But at least for minutes and seconds, that works. That also works for degrees. Like when you measure angles, 1/60th of a degree is called a minute, and So that's a very, very small angle. And when you divide that angle, that minute, into 60 pieces, those are called seconds also. And in astronomy, you sometimes need to have angles measured to really to high accuracy. So minutes and seconds they're almost like decimals, like 5.23 degrees, but it's like 5 degrees, 30 minutes, 5 seconds. And it's all because the Babylonians had what's called a base 60 number system. And that's how we're going to start the course, with the Babylonian number system. I'll go to the next page. Now, the Babylonians would write their math, their numbers, with on clay tablets, and they had the clay would be wet, and they had some kind of like a thing that they call this, that we now call a stylus, and they can make little markings, which kind of looked like these like triangles. So something like that would be the number 1. And if they had 2 of them next to each other, that would be the number 2. And they can kind of just group them together all the way up. They would arrange them in like a square. That would be the way they would write the number 9. Now, to write the number 10, they would take one of these wedges and they would make it like sort of diagonal. And if they wanted to make a number like 37, they can take 3 of these sort of diagonal wedges. I'll make those a little bit more obviously diagonal. This is Babylonian, yes. So our first 3 days will be all Babylonian. And by the way, I'm only showing you these little numbers things just for a few minutes, but we're going to switch over to a more convenient way to write this stuff. But I do want to show you that they would write their numbers like the number 35 would be 3 of the 10s and 5 of the 1s. So you might look at that and say, well, isn't that base 10? You know, this is like the 10s place and this is the 1s place. And in a sense, yes, there is a little bit of a base 10 thing going on. So where is this base 60 coming from? Well, we're not going to have to make all these symbols. We're going to write the numbers as 2-digit numbers. So 01, 02, up to 09, and then we start getting, 10, 35. And then we'll go up to the number 59, which would be, 5 of these diagonal ones and 9 of these of these upright ones. So at this point, you're feeling like Babylonian is just base 10, just like we have. But something kind of weird happens in the Babylonian number system here, which is going to be kind of funny to us. 2 things about it. After 59, whoops. Sorry, forget those things. After the number 59, the next number in the Babylonian system, we're going to write this way. Almost like 59 minutes turns into 1 hour. So this 59 is the number 59. But this 0100 is actually the number 60. And I'm going to explain this a little bit in more detail, but I'm just going to, this is how they would write 61, sort of a 1 and a 1. That's how they'd write 62. And this would continue until, remember the warm-up question? 0159, this 01 represents the 60s place. And this represents the ones. So 0159 is really 160 plus 59, which is 119. So the next number would look like this. Which would be a way of representing 120. In other words, it has two 60s, that's what this place is, and no ones, and that's 120. Now, don't worry, I'm going to go through this in a lot more detail, but I just wanted to show you. Now, technically, the way this would look is kind of confusing because they would have like for the 159, or even here, the 1 would have a little symbol for a 1 and another symbol for a 1. And you might say, well, how do they know that wasn't 2? Because the number 2 has two of those wedges also. So the answer is it was a little bit confusing. And that's why when we write about the Babylonian stuff nowadays, we don't make these little symbols, but instead we write it this way. Let me go to the next page and show you a little bit more about this. So imagine I had a number that nowadays I'll write as 0403. I want to compare this to the number 43 in base 10 to help you understand what's going on here. So here's base 10. And in base 10, the 3 is the ones place and the 4 is the tens place. So this represents 43 on the right here, 43 things. If I were to actually draw it, I'd have 4 groups of 10. And 3 ones left over. So this number 43 is a way of talking about those 43 dots. And for the Babylonians, they could also write 43 that way. At least that's how we're going to write it. 43 represents 43 dots. But when I write this thing, that is not 43 anymore. Because in base 60, this is still the ones place. So there's 3 ones, but this place is the 60s place. So you can type into question number 2. What do you think? It looks like 0403, but what is it how many objects in our sort of way of thinking about it in base 10? What is that really saying, 0403? Go ahead and type it into the Desmos activity. I'll just see if people are and by the way, these questions now are not being shared with the whole class, which means if you're confused, that's where you could type in like, even if it was getting shared with the class, it's fine. If you feel confused and you want its help, you could ask questions and say, hey, I'm a little confused. Could you explain that in a little bit of a different way? But for now, if you could type in, what do you think 0403, what number in base 10 do you think they're talking about? Okay. Okay, and I see not everyone answered, but the Desmos code. I'll write it down over here again. It's N643. This is a B and then F. So if you go to student.desmos.com, you can log in there. Okay, good. So most people did get this answer right. The answer is 243, and let me go over that because some people hadn't gotten it right. So this 04 basically means 460s. And the 3 means add on 3 ones. And that's why, yes, it looks like 04, 03, but it's actually in base 60, which is the same thing as the number 243. Sometimes in this base talk, we throw a little number there in the little subscript so that we can tell, because it gets confusing. Like, is that 243 a base 60 number? What is it? So I put the little 10 there. Now, it's not necessary to write a little 60 here because it's clear from the fact that there's like these groups of 2 digits, 04, 03. But if you like, if it helps you, you could write a little 60 down there. So the number 243 is 3 10s, so 3 ones, 4 10s, and 2 100s, which is the same number of things if I split it up as 4 60s and 3 ones. They're both ways of describing 243 things. And just for fun, I could say 4 hours and 3 minutes is how many minutes? And the answer would be 243 minutes. Now there are other bases besides, and just through the chat, anyone who's a teacher ever teach their students like base 2 or just any other base like base 5 or any other base, you could type into the chat. Just it's sort of an enrichment thing that some teachers teach. Sometimes there was a time where they wanted to teach like little children different bases and then say that like base 10 is just one of the bases that you could possibly study. But it ended up being really confusing. Only base 10. Mm-hmm. Yes. So with smaller kids, you might do like almost like a base 1, like there's a bunch of dots that like each correspond to an individual number or the things are matching up with each other. Okay, now here is a challenge question for you. By the way, I think even before I do that, I'm going to show you something. If you're struggling with bases, odometer, I always like this graphic. Not that one. Huh. Let's see. Base numbers, odometer. Here. I always like this. Check this out. When here, I can't make base 60, but when I click start, watch what happens. I'll make this go kind of slow. So look, if you look at this carefully, you can see the decimal, 7, 8, 9. It went to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But you can see there are these other bases. If you look at the one that says octal, it looks like it's just 32, 33, 34, 35, 36, 37, and then it turns into 40. I'm just going to pause this at a certain time here. So these are all ways of representing the same number. 36 is 3 10s and 6 1s. In base 8, the 4 is still the ones place, but the other 4 is in the eights place. So it's 4 times 8 is 32 plus 4 is still 36. In binary, base 2, this 0 is in the ones place. The second 0 is in the twos place. The third, the 1, is in the fours place. The next 0 is in the eighth place. The next 0 is in the 16th place. And the next 1 is in the 32nd place. And 32 plus 4 is 36. I just wanted to kind of mention that some people like to see that. Let's go to the next page. and let's go to the next question. Here's a challenge for you. What do you think a 3-digit, yes, you might say this isn't 3 digits, this is 6 digits. No, these are 3 base 60 digits. Each digit itself has 2 digits in it. But this is a challenge for you now. What do you think happens? This is a large number. But what number do you think it is? Why don't you go ahead onto the into the Desmos activity? And I'm curious, what do you think the answer to question 3 is? And you could type the numerical answer, or you could put in some work if you want. This is very interesting because I see there's a lot of good ideas, and there's only one correct answer so far, but that's okay because this is exactly. I really like what I'm seeing. Some people are typing in some different ideas, like almost like a chat with me. Uh-huh. Okay. You know what? This is very good. Even though only one answer was officially correct, I liked I like what I'm seeing there. So let me tell you and where's my, hold on, let me get this. Let me tell you that the answer is not what you think for what most people think, but the answer is a pretty large number, and I'll go over why it is. But the answer is actually 15,007. Now, what? 15,007? Well, let's see why that is. Here's a number like 487 in base 10. In base 10, the 7 represents the ones place, the 8 represents the tens place, and the 4 represents the hundreds place, otherwise known as the 10 squareds place. Well, in base 60, the 7 still represents the ones place. But this second position is the 60s. And the third one is not the 120s, which is not a bad idea, but it is actually the 60 squareds, which is 3,600s. Just like in base 10, the 100 is 10 squared. So those people, a few people said that perhaps the 4 was in the 120 spot. It's actually the 3,600 spot. So the way you do this question is 4 times 3,600 plus 10 times 60 plus 7 times 1, which is a large number, 15,007. So in this, so the number 010000 is actually 3,600. Four times 3,600 is 7,200 plus. Did I do something right? I feel like I did something wrong here. No, 4 times 3,600 is 1,000 is 14,400. 10 times 60 is 600. That's adding up to 15,000 plus 7. Okay, does anyone have any questions about why this 04 10 04 1007 in base 60 is actually the number 15,007 and not what you might have initially thought? Anyone have any question? You could type it into the chat if you don't like to unmute and talk, but if there's any questions about that. So as you can see, just from this one thing, this is what this course is going to be. It's like an unfamiliar world where it's not that the math is, it's more confusing than it is hard, and it's unfamiliar, and it's looks like stuff we already know. So it's like we feel like, oh, this is probably easy, but then it's like it just puts us in this, like, we definitely get out of our comfort zone in it. Okay, but if there are any questions at any time, you want me to do another example, for instance, you can just ask me. I'm not in a rush in this course at all. Like, I do have like 30 topics that I'm planning to cover over the 15 days. But if I have to go slower and I only do 27 of the topics, it's fine with me. I would just, remove a question from the final exam, and that would be fine. Okay, so that's what base 60, that's how base 60 works. But we have to do more about base 60. So the next question is, can we go, and I should just mention that, yes, we write our stuff like this, but in the Babylonian days, it was pretty complicated, especially if they wanted to write something like 020005, which is 2 3600ths, which is 7,205. They actually would make like a 2, and they'd make a 5. But they didn't actually, they didn't have a 0 yet. And they didn't like know to put a placeholder. So it was really confusing about what numbers they were, different numbers could be written the same way. Just like if I put a 2 here, that might have represented 2. It might have represented 0200, which is 120. Yes, Letitia, you can unmute and speak.
Is the number 7,250 or 7,205?
Ah, sorry, it is 7,205. Thank you. So if I had a number like a let's pick, if I just had a single mark, that could be 1. It could be 0100, which is 60, and it could be 010000, which is 3600. So you'd have to know, if someone says, my grandmother, is 1 year old, is the symbol, well, you would know that they meant 60, because by the context clues. Okay, the next thing, and as I mentioned, we're not really going to be using these symbols because this math is confusing enough when we get to use, 2-digit Arabic numerals. Oh, and Letitia, just to make sure I see the hands up, is that up for a second question, or is that the same one as before? Okay.
Sorry.
That's all right. Now, the next thing we want to be able to do is, can we go backwards from base 10 to base 60? So here's the number 220 with a little 10 there. Sorry, my first 2 is a little bit, redraw that. And I don't know, do I have this as a question? I do. This is more, I haven't taught you specifically how to do this, how to go backwards, how to go from base 10 to base 60. But what I like to do, and I hope if you're math teachers, you like to do this also, you ask a question that hasn't been officially answered yet. Go ahead, try to answer this right now. Okay, I'm taking a look. What do you think? I've not taught it yet, so don't feel bad if you're saying, wait, I don't know how to do this yet. But I am curious, 220 in base 10, what would that look like in base 60? The same, the same number. Okay, so I see there's so how many people? So one, two, so I only see 4 answers so far. One, two, and I see 5 answers, and two people have it correct, and 3 people have some error in there. So you don't know, we don't know yet which one, but examine your answer. Now, I hadn't taught you how to do this yet. Okay, so the answer, and again, no one should feel bad if they didn't get this answer. But it's something that I'm going to teach you. The answer should be 03 0340, and I'll explain why that is. And of the 5 people who answered, only 2 people had that. So if you're someone who didn't have it, you don't have to feel like, you were the only one. But let's just verify that this is true at least. So yes, if I do 3 times 180, well, 3 times 60, and I do 40 times 1, it does become 180 plus 40, which is 220. So we can see that yes, 0340 is the correct answer. But now let me teach you a method for doing that. So here's the way we do that. Here's a method you could use. There's a couple of ways of doing this, but I think the easiest way is to first notice that 220 is it's bigger than 60. Sorry, it's bigger than 60, but it's less than 3,600. So I'm just going to make a note that 220 is definitely less than 3,600, but bigger than 59, which means we should expect our answer to only have 2 base 60. They don't call it decimal, by the way, they call it sexagesimal. So we're going to have some number in the 60s place and some number in the ones place. Now, what I like to do, I, there's different ways to to do this. Um, you could, if the number is small enough, you could just subtract away 60 over and over. 220 minus 660 is 160, and then subtract 60 away from that, 100, and then subtract 60 away from that, and get 40. And you can see that there were 3 60s I had to. Basically, 220 is between 180 and 240. So the 360s, and then the 40 is kind of the number that's left over. But that method is only good if these answers are small numbers. So a second way that you might prefer to do this question is to divide 220 by 60 and see how many times it goes in. And in that case, the 3 would be the 60s place, and the 40 would be the tens place. So that's one way that you can do that. Now I have a challenge question for you to think about, which is question number 5. Here I have, what about a larger number like 8,150? That's in base 10 right now. I want to turn it into base 60. Go ahead, take a minute or two, mess around with that question. I am going to teach you how to do it, but for now, I'd like to see, like, what do you think? And let me take a look over here. So we're on question number 5 now. I kind of wish if we were in person, people would be talking to their neighbors, and discussing this. But when there's 10 people, we can't all it doesn't work as well. 10 people in a Zoom doesn't work as well as as having 5 groups of 2. Of course, I could put you into breakout rooms of 2 people, but again, it just doesn't work as well. In person is definitely better for that.
Professor, can you have more than 2 digits per place?
More than no every base. Good question. The biggest number in any position is the biggest number would be 59 in any of the little positions. So I hear what you say. It's almost like you need more than 59. You might need more than 100 60s, but no, you'll need another place then.
Okay.
Okay, so I'm looking over. Mhm. Now, just to get our bearing straight, the number 010000 would be 3,600. That's in base 60. And the number 020000 would be 7,200. And 030000 would be 3,600 times 3, which is 10,800. So our answer needs to be between 020000 and 030000. So if your answer is not something like that with three digits, three base 60 digits, which each themselves have 2 digits in them, your answer should be something beginning with an 02. That's a hint for you. Good. That hint has helped people out a lot because now of the not everyone answered it, but of the people who did answer it, they're almost all correct now. Now, why are there 2 people who are still stuck on question? Oh no, there's people. Oh, I see. Someone went back. Wait. Yeah, there's one person. Okay, so now we have almost everyone. Oh, you should know that I could see what page you're on. I don't know if you guys used Desmos Activity Builder if you were teaching during pandemic, but it's really good free thing. Of course, they're starting to sell their curriculum to schools now, and it will probably be a waste of money. But this free thing is very good. If I see you're stuck on it on the wrong page, I'm just gonna type something to one of the people. Hold on. Yeah, you definitely don't want to do I don't know what it's called, where you're on the Zoom, but you're actually, working, another job at the same time. You're like at work. Don't want to do that. Uh, so the Desmos is how I can tell if people are with me here. Okay. So most of the people did get the right answer, which I'm going to write down here. And I'm going to go over how to do that because not everyone got it right. So it's okay. 8,150 in base 10. So because 8,150, whoops, because 8,150 is between 3,600 times 1 is 3,600 and 3,600, whoops, 3,600 times 2 is 7,200 and 3,600 times 3 is 10,800. Basically, what we're expecting is 3 base 60 digits. The reason why it has to be 3 digits is because the third digit is the 3,600th place. And the fourth digit, I've almost never seen I've never seen anyone practically, use a 4-digit. Like the next digit would be the 1,216,000 place or something like that. So we're only going to do these. Our numbers are going to stay smaller than 60 to the third power. So here's what I'm going to do. Maybe this is the easiest way to do it. we divide by 3,600 because it's bigger than 3,600. So there's something in the 3,600's place. And the answer is it goes in twice because 3,600 times 2 is 7,200. So this 2 becomes the number in the 3,600's place. Now you subtract, and we get 950, which is like the remainder. Now 950 is bigger than 60, so now I could take 950 and divide it by 60 and get 1. And I got myself confused here. 6 times 5 is 300. So this 15 ends up becoming the 60's place. And then the leftover, the 50, that ends up becoming the 1's place. So if you're a little confused, partly you should know is that the way I've been teaching this in a little bit of a, what's it called? Inquiry-based learning. How many people use that as teachers? You could type into the chat. Is that a strategy you use while teaching? It's kind of like a buzzword. Aha, Letitia, illustrative math. So inquiry-based learning is where you try to, before you tell them the answer or the method, you try to get them to figure it out. And even if they don't figure it out, if they do figure it out, of course, that's great. Then they understand it before you even taught it to them. But if they don't figure it out, it's not bad because they're a little more invested. They tried to figure it out, so they were thinking about some of the issues and maybe they got close. And even if they don't figure it out at all, there's a little more investment because when you go over it, they're like, oh, that's what it was, as opposed to just some random thing that they never thought about. So if you're confused, keep in mind that I will always at the end, I guess in a true inquiry-based learning, you never see, I think you can go too far with inquiry-based learning where the teacher just never tells here it is, here's the deal. And I guess the philosophy is if the students know you're eventually going to tell them here's the deal, they may not put as much effort into the question. It's a very tough balancing act. I've never been able to go full scale 100% inquiry-based learning. My students get too confused. Maybe it's because I break down and tell them it. I don't know. Does anyone feel like they push the inquiry-based learning to its extreme?
It doesn't, sometimes it becomes too ambiguous. So you got to think about as you're planning your math and you know your students in terms of your observations of how they think. Sometimes it's applicable and sometimes it's not. It'll make when you model and explain that application too difficult for that transfer. So you got to know when to do it and when not to do it.
That's right. Very good. That's how I agree with that. Full scale. So far in this course, we have learned basically when you might be wondering, there's a final exam on the last day, right? And it's about 30 questions. And based on what we've learned so far, one question would be something like this, turn 041007 into base 10. And one question that there's about 100 questions that I could ask, but these would be like examples of of those, and then going in the opposite direction. At this point, those are the two things that, those are skills that you should expect. If you're like keeping track, because the final's a little scary because it's worth 40% of the grade. But I will tell you that last time I taught this course, like 80% of the people got a 90 or better on the final. But these are like little skills. So when it comes down to it, you'll be asked just numerical questions like this. Okay, so 10:30. This is pretty good. I'm gonna do a break at 11. I'm gonna do a break half.
Have our notes?
What's that?
Will we be able to have our notes?
No, for the final, it's not an open notes test, but I will make sort of a review sheet that will have you'll be pretty ready for what possibly could be asked. So it's not an open notes test, but so far you can see that the two questions I would ask are converting a number from base 60 already into base 10 or going backwards. Now we have homeworks, and I'm going to make the homework due on Monday each week. Now I think it's better if you try to do the homework each night, but I know you guys are adults and you might have your families and you might have jobs and other responsibilities going on. So I'm going to make all the homework due on next, the first 4 homeworks are due next Monday. So I hope that helps you out. Some people prefer to have the homework due the next day so that it keeps them, you certainly can turn it in the next day. Okay. We are now, or I'm ready to go on to fractions or decimals. How do you deal with numbers that are less between 0 and 1 in other bases, particularly base 60? So here is a base 10 number, 243.27. This is base 10. I'm going to put a little 10 here. You know it's not base 60 because base 60 has like these groups of 2-digit numbers. So this is the hundreds place. This is the tens place. This is the ones place. After the decimal point, the first place is the tenths. And the second place is the hundredths, which is also 1/10 squared. That's our base 10 system. So this happens in base 60 also. So here, I'll go 0115. That's the number 75 in base 10. Or that's how you write 75 in base 60. That's 60 plus 15. Now, instead of using a decimal point, by the way, they didn't use anything back in those days, so it was really ambiguous. But we will use, instead of a decimal point, we will use a semicolon. This is just like 100 years ago when they started really studying the Babylonian math. They decided, to do it this way. So now I have 2 more numbers after the semicolon. In base 60, this is still the 60s place. This is the ones place. But the 7 is not 7/10 or 7/100 or whatever, but it's the 1/60. And the 30 is 1/60 squared, which is the 1/3600. Now you might remember if you taught elementary school, you did those what are those blocks called? They used to call them Cuisenaire rods. Is that still what they call them? Base 10 blocks, maybe? You know, you had like the little squares, and then you had they called them the longs, base 10 blocks. And then they had these like 10 by 10, and they call them flats. They still call them longs and flats.
Yeah, they do.
They
At
do.
least that's
Good.
what I still hear.
Now those are great tools, right? They just the cubes, the longs, the flats. Oh, they did cubes also for thousands, for thousands. Well, if they invented these in the uh Babylonian times, the longs would have to be 60 units long, and the flats would be 3600s. They'd be 60 by 60. So we're happy we have base 10 for teaching kids. Well, check this out. So this is the number 75. Now I'm not going to use the decimal points. I'm going to use fractions now. Plus 7/60ths plus 30 over 3,600. Oh, you know what? To make it like even more, why don't I write it's 60, right? This 1 represents the number 60. This 15 represents the number 15. This 7 represents the fraction 7/60ths. And this 30 represents the fraction 30 over 3,600. Would you please, using like common denominators and such, combine these fractions and reduce to lowest terms and watch what happens. Something surprising will happen. Is this and you could do question number 6 then. Once you get the fractional part, you could type the answer for what that fraction is reduced, so I can see that you did that right. So head over to question number 6. Now, when you combine with like term common denominators at the end and then reduce the fraction, you're going to be like maybe surprised by the answer. So everyone take a moment to try to get that all the way down. Okay, uh, I see, a lot of people got this correct. Surprisingly, this 7/60 plus 30/3600, it does become, if you get common denominators, you know what I like to do when I'm doing this? I like to reduce the fractions before I add them. So 1/120, which becomes 15 or 14/120 plus 1/120, which is 15/120. But 15/120 itself reduces to 1/8. And 1/8 was the answer to that question. So now, so that's kind of surprising. Surprising way to write 1/8. You see, in time, when I say a half hour, well, that's the same thing as 30 minutes, which is the same thing as 30/60, which in the base 60 world looks like that. Whereas a quarter of an hour is 15 minutes, which is the same thing as 50/60 hours, 15/60 hours, which in base 60, you'd write as decimal point 15. But an eighth of an hour is half of a quarter of an hour, which is 7 minutes and 30 seconds. And notice in base 60, 0730 is what we just did, is the same thing as 1/8. So it's kind of funny. If I just asked you, what's 1/8 of an hour, you'd be able to figure out it was 7 minutes and 30 seconds. But yet it is kind of confusing when you see semicolon 0730 being their way of writing 1/8. That is, pretty confusing. But for our purposes so far, we haven't had to go the other direction. 0730 is the same thing as 7/60 plus 30/3600, which eventually did reduce to 1/8. Now, let's see what question 7 says. Chart. So we actually did a few of these, right? Semicolon, semicolon 30, semicolon 15. I don't even have 1/8 on here. I only have one. So why don't you fill in the other ones though? What do you think? Think about time. Think about half an hour is 30 minutes. Quarter of an hour is 15 minutes. How about these other ones that you can do? 1/3, 1/5, 1/6, 1/10, 1/12, 1/15, 1/30. That last 1/20th, sorry, and 1/30th. You can fill out that chart.
It won't let me submit the chart. There's no submit button.
No, it doesn't, you don't need to submit, it just pops up on my, it just pops up for me, without, no, not necessary to submit, because it automatic, every time you do a keystroke, it does it. Okay, so we have 30, 20, 15. A fifth of an hour is 12 minutes. A sixth of an hour is 10 minutes. For a tenth of an hour, it's 6 minutes, but I'd prefer you write 06 so that these like sexagesimal places themselves always have 2 digits in them. The reason I say that is because if I say like 6-5, or well, let's just imagine, 1-3 versus 01-03, those are different things. So it's less ambiguous if I make each of my places 2 digits, even if it's only a 1-digit number. 3 minutes is 1/20th of an hour. 2 minutes is 1/30th. I threw in 1/60 because might as well. So these are all the nice sort of decimals I could make to represent various fractions. What's kind of funny about this is that when you go to, if you go to base 10 instead, you have 1/2 is 0.5, 1/4 is 0.25, 1/5 is 0.2, 1/8 is 0.125, and 1/10 is 0.1. 1/3 doesn't work out nicely in base 10 because you need repeating decimal, 0.333. Same thing with 1/6. But in base 60, you can do 1/3 nicely. And actually 1/4 and 1/4 is a 1 digit. I know the 1 digit has 2 digits in it, and we didn't get to 1/8 yet. But so those are some basic fractions. Now let's go to the next page though, and I have a challenge question for you. That's not the challenge question. 1 second. No, we're not. This next thing isn't going to be on a page. It's just going to be over here. So we have seen that 1/8 can be rewritten as 0730. But I haven't taught you how to actually do that, how to actually like have calculated that. But well, actually I did. I said 1/8 of an hour is 1/2 of a 1/4 of an hour. But here's a challenge question for you. This is just, it's pretty hard actually. I like it though. What do you think 1/9 is as a base 60 number?
Is that 6.6 infinity?
Is it? It's actually not repeating. It terminates.
Really?
Yeah. There could be repeating decimals in base 60, but not for 1/9. 1/9 will terminate, just like 1/3 terminates. So everyone think about this one for a minute. This is a challenge question. I'm going to teach you a technique for these, but this is the illustrative math, inductive, no, what's it called? Inquiry-based learning. What do you think 1/9 would be written in this base 60 like decimal thing?
Should we write our answer in the chat?
Oh yeah, you can type it into the chat because this is just sort of like this is sort of the challenge question. It's actually a pretty interesting question. I like it. It's hard, but I'm going to teach you a technique for it. So type into the chat if you think you know what the answer is. It's going to be a 2-digit number, but each digit's going to have 2 digits in them also. And you could type it to everybody or directly to me. I got one answer. It's close actually, but not exactly right. A second answer that's close, but not exactly. So I haven't seen an exact answer, though I have seen close answers. Okay, I see 2 answers so far. Neither are exactly right. That one's updated, still not exactly right, but closer. But no one's written anything for the other ones. I guess I could give a hint and say, what's 1/9 of an hour? How many minutes and seconds is that? Okay, third answer. No one has the exact answer yet. There I see the exact answer. So first I'm going to write down what the answer is, and we could just see why. Oh, so the answer is 0640. And let's just verify before I tell you how you might have gotten that. That's 6/60 plus 40 over 3600. I like to reduce 1/10 plus 1/90, which is 9/90. Wait, I got myself confused. Yeah, plus 1/90, which is 10/90, which is 1/9. But you say, okay, we could verify as the answer, but is there a method for calculating that? And there is. Here's the easiest way to do these. I'm going to come to a new page for that. I'll show you with 1/8 first. You go like that. 1/8 is how many 60ths? And basically we end up dividing 60 divided by 8. This is for 8th. And you get 7. But you get a remainder, 7 and a half. So for 1/8, it's 07. Now the half, what do you do with that? Well, on the side, you could turn the half into 60ths. I'm going to use a different letter. And you get 2y equals 60. Basically, you might say, well, why not 3600s here? Well, it's because this is 7/60ths, and this is, and now I got myself confused. 7.5 60ths. So it's like 7.5 60ths, which is the same thing as 7/60th I'm trying to think where the 120, you know what? I got myself a little confused about it, but this is going to be our process. We're basically we're turning the half into 60ths, but because it's not really 60ths, because it was really hold on. I got there's a little detail that I'm a little fuzzy on right now. For now, I'm just going to say that this will work, and I'm going to move over to 1/9 and show you it working for that one also. So you have a process. 60 equals 9x. X is 60 over 9. 9 goes into 60 6 times. And I get remainder 6. Which is 6 2/3. So 6 is the first place. And then I take the remainder, the 2/3, and I turn that into 60ths. And it becomes 40. Which is the right answer. There is something a little bit confusing about this process. 6 2/3, 6. I just got to think for a second. 6 2/3 60ths is 6 60ths plus 2/3 60ths. But I want that to be 30. So there's like a slight detail that I'm like fuzzy on myself. But I promise if you do this process, it will work. Essentially, you're turning the remainder, that fraction itself, into a six into base 60, but we're putting that answer into the 3600ths spot. So maybe I should give you one more question of that sort. Let's say we did 2, 3, 4, 5, 6, 8, 9, 10. We'd never do 1/7 with this because it would make a repeating decimal. We did 8, 9, 10. We would never do 1/11. 12 we did. 13 we would never do. 14 we would never do. 15 we did. Maybe 1/18. Would you go ahead and try to do this process with 1/18 and just see what happens? It might get kind of weird, but go ahead and try it anyway. There's a chance it becomes 3 places. I forget if it becomes just 2 or 3, but go ahead and try to do it anyway.
Professor? Professor? Professor?
Oh, hey, what's up?
So I have a question. So let's say you did it for the, so in your process, right? You first did the given fraction and then equals to a number that has a denominator of 60.
That's right. That's how I can get this position here. That's right.
Now, if you get a remainder, right, from that from so you, and even if you get a remainder, you divide again, right, and then base by 6, you divide again. Now, what if on that second
Yeah,
division you
that
get a remainder? Do you add another one?
no, yes, that's right. If you got another remainder, you would turn that into 60ths again to get the third place. So that could happen.
Okay.
So in this one, we get 18x equals 60. X is 60 over 18, which is 3, which is 54, 6/18, which is the same thing as 3 and a third. Now, so 3 goes here, and a third, you could, if you know that a third is 20/60ths, you could just do it right there. Or you could say 1/3 equals, I like to say y over 60, and y becomes 20. But you're right. If there was a remainder there, you would then take that remainder and change that equals a z over 60, and that would get you the next decimal place.
So I have a quick question about that
Yes.
for the second part when you put 1/3 equals y over 60. Is that possible because like you already did denominator of 16 and you're doing another, so that's like technically 3,600. That's like the part that's
Yeah,
making
why
me
it
a little
works.
stuck.
It's a little
Yeah.
confusing. I used to understand. So it's kind of like we're putting 3 and a third, which isn't really a
Mhm.
thing that they're allowed to do, into this single spot.
Right.
But how does that translate? So a third of a 1 is 20/60ths, but a third of a 60th. I got myself a little confused. I used to completely have this mastered, right? I'm confused about how we're just kind of putting this here. I think I could explain it. I think I could explain it if I do it with base 10. So let me
Mhm.
try that for a second. 1/4. Imagine I tried to do this process in base 10. I would say 1/4 is x over 10, and 10 is equal to 4x, and x is equal to 2 and 2/4, which is 2.5. So the 2 goes here. Now this half is equal to 5/10, and the 5 went there. So it's like 2.5, which it's kind of like 2.5. And that 0.5 itself is like 0.5 it's like 0.5. It's not 5/10, but it's like 0.5, which is the same thing as 5 over 100. So it becomes 0.25 like that. That's sort of the reason. If that's even it's like 0.5 is the same thing as 5/100, and in a similar way, 20 20/60ths is it's kind of like that. It's a little confusing though. I'm gonna have to reponder this to like give you a better answer for it. But for now, it definitely works in that it got us the right answer for this. If you add 3/60ths plus 20 over 3,600, you will get 1/18. So at least it works. but it is a bit confusing why that works. I gotta like I'm gonna revisit that probably tomorrow when I look at this again. What I want to do now is take a 10-minute break and come back and show you about adding, subtracting, and multiplying. So let's all take a 10-minute break and relax. I'll be actually here during the break, so if someone wants to like ask me questions, I can answer them. But everyone else, I'll see you back here in 10 minutes.
Professor Rubenstein, I had
Yes.
sent you a message. My second course, she hasn't sent me any Zoom information for my 4 o'clock class.
Oh, so I don't know. Like we don't coordinate. Like I just teach this one, but I will tell you that there were two students who were supposed to be in this Zoom class right now
Mhm.
that somehow didn't get an email from me, even though I sent an email to all the, to all 10 people. So there's a chance. So I think you should email, her name's Laura. Um, Let me give you her email address because Laura Gellert. So
Mhm.
let me send, because she,
What's her email address?
I'm going to send it, I'm going to type it to you right now. Hold on. Hers is LGELLERT at ccny.cuny.edu. So she's sort of like the chairperson,
All right.
and
Thank you. I had went on Blackboard and I had updated my email. That's how I got yours. Because
I
this
got
happened with my first course, but I didn't get anything. And when I went on Blackboard, there was a message and I'm not able to read the message for some reason, but I'll email her now.
okay, great.
Thank you.
You're welcome. Okay, everybody. Welcome back. Now, doing arithmetic, meaning adding, subtracting, multiplying, dividing in base 60. Well, adding and subtracting are pretty easy. You might remember if you taught elementary school, you would sometimes have to add together things like, oops, oh, good, someone's coming on in. Okay, welcome. I see Stephanie, you're in now. There was some confusion.
Hello.
Hi, there was some confusion. I sent emails to all people, but maybe some didn't come through. So this is our Zoom, and I'm going to post
Okay.
a video of everything we've done so far. What we're doing
Okay.
right now is going to remind you, you might remember back in the day in elementary school, they used to teach this kind of thing a lot, where they would say like 2 foot 8 inches, 2 foot 8 inches plus 3 foot 7 inches. Or maybe they would say like 3 foot, 2 inches minus 1 foot 8 inches.
Okay.
And it was actually a hard thing to do because what you would do is you would go like 15 inches and 5 feet, but then you would turn the 15 inches not into like carry the one, not like 6 foot 5 inches, but instead you would change this to 6 feet and you would sort of turn this into 3 inches because 15 inches was
12.
you took away 12. And subtracting was even more confusing because you would go like this, 2 inches is less than 8 inches, so you would do like 2. But then you would turn this 2 inches not to 12, but into 14. And then you would subtract. Well, we're going to do a similar thing now. And you might have done this with time also. So let's look now in this, my next question is, what do you think happens if you add in base 60, 2140? And I'm also, Stephanie, going to give you the Desmos code. Let me see where that is or how I do that. Hold on a sec. I'm going to post this into, wait, it's not there, but it is.
I've used Desmos before, so if you need to send me things after class, that's fine.
Okay. No, there's a code that I wanted to give you. If you could type your answers in. Does anyone? Oh, you know what? I have the code from the very first slide. Hold on. The code is. Where did it go? Hold on. There it is. So go to student.desmos.com and the
Okay.
code is N643 letter B and letter F.
So M as in
And like, oh, I was writing it down, but I didn't have the right here. Here it's written down over here. So N letter.
N6. Yeah, I see it.
Okay.
N643 BS.
That's right.
Okay. Thank
Now,
you.
here's a question. So we've been doing this Babylonian base 60 number system, and it's confusing because each digit is represented with 2 digits. And this number 2140 actually is a very large number because it's 21 times 60 plus 40. So it's really large. But we can add these numbers together in base 60. And the way you do that is you add the 40 plus the 35 and you get 75. The thing is, and I'm going to actually leave it as a 75 right now. But in base 60, the biggest number is 59. So what you have to do is you have to carry. Basically, 75 in base 60 is written as 0115. So what you do is you take away 60 from the 75 and you add 1 the 35. And that's the same thing you would do with time. If they said, what's 21 hours, 40 minutes plus, yeah, and it is 36:15 is the answer. Now, I permit you, like on a test or something, if you want to do it the way I just did it, where you first just add the two things and then just take away 60 and add 1, that's perfectly fine. But if you prefer, just because you want to like get your mind into the way the Babylonians would do it, they would never write a 75 here. They would just go 40 plus 35 is 115, so they'd put a 15 here and carry the 1. Personally, I wouldn't do it this way, but I permit you to do it. Now, converting, do you mean, Letitia, that you literally turn these into gigantic numbers? Like 21 times 60 plus 40?
Yeah. Yeah.
Okay, so that I'm going to recommend against, only because it will be easier to do it this way. And we want to like get into like the Babylonian like state of mind. So it would be better to do it this other way. But you'll get the same answer if you do what you described. But for instance, that way would require a calculator, whereas this way here doesn't. Now I have a challenge question for you. Wait, this is the one we just did. Now look at question 9. What do you think about subtracting 2115, which is a large number, minus 1340? And I'm going to bring that over here also. 2115 minus 1340. Here you go. How do you think you subtract these base 16 numbers? Everyone, you can go ahead and type your answer into the, this is question 9. Okay, let's take a look at what people are saying. Okay, so I'm going to recommend not. I see Stephen. Don't change it into base. Don't change it into base 10. That will be harder. You might remember this from time, and you need to borrow. 15 is less than 40. So you need to borrow. So you trade, basically, or whatever you call it, trading, borrowing. You change this to a 20. And someone want to just unmute and say, well, what happens to the 15?
It becomes 75.
That's right. And you might remember this from when you taught, really, I don't know if this is a thing they teach anymore with feet and inches and stuff. That used to be like a big thing back in the 70s. I don't know. They might still teach it. But you added 12 minutes, and similarly over here, you add 60. 2075 is the same thing, and then you can subtract to get 35 and 7, which is the answer. What's funny is that when the Babylonians themselves might do a question like this, incidentally, they didn't teach this to kids. They were like people who were like professional mathematicians, and they were like, kept count of stuff. So they knew how to do this, but it wasn't like a thing that like the average citizen would know how to do. But just to tell you that it would look something like this. the 75 is still 0115 to them, you know. But I'm modernizing things so we can do it. The next question, so that's adding and subtracting. Now, multiplying is kind of funny, so I'm going to write down 23 times 24. Now, they had 3 ways to multiply that I'm going to take you through. And the first one is, if you go over to the Google Classroom and you look at the document that says Babylonian arithmetic, it has the homework assignment. Although I'm removing this, I'm not, there's no delta math. Let me get rid of that question. And down here, we have a chart. And it says the 23 times table in base 60. So to multiply by 23, you would have this chart here that I have on the screen. You can see that. And you can see what this is 23 times 1 is 23. 23 times 2 is 46. 23 times 3 is 69, but they would write it as 0109 because that's 60 plus 9. 23 times 4, you can just add 23 to 0109. And they go all the way up to 23 times 10, which is, it says 0350, but 0350 is 180, is 03, that's 60 times 3, plus 50 is 230, which is 23 times 10. And then they skip to 23 times 20, 23 times 30, 23 times 40, 23 times 50. Let me make this so it's all on the same. There we go. It looks like that. Now they would have to have, believe it or not, one of these they'd have to have 59 of these tablets. One for each number from 1 to 59. So let me show you how you use this chart to do 23 times 24. Very simply, you would do 23 times 20 plus 23 times 4. And those answers you would look up on the chart, and on the test, I give you the chart. So 23 times 20, you go over to the chart, 23 times 20 is 0740. It does not matter that you know that that's their way of writing 460. That's just what 23 times 20 is. And 23 times 4, according to the chart, is 0132. And then we add those two numbers together. 40 plus 32 is 72, but I'm just going to write 12 and carry the 1. And yes, Letitia said 09. I think you said, yeah, I said 0912, which is the answer. Now, what does that equal? Doesn't matter. like what is it in base 10? In their world, 0912 is how they say, 9 times 60 is 500. That's 552. But it doesn't matter that it's 5. What matters is I wanted the answer in base 60.
Question?
Yes.
I'm confused about the last step, the way you added here.
Yes. So what if instead I do it this way? 0740, 0132, and I just write 872. Well, the thing is 72 is bigger than 60. So that they would never have the number 72 in their ones place. So I take 760 away from 72 and I add 1 to the 8. Is that better? So I did it in sort of like 2 steps.
Yes. Thank you.
And that's the answer. That's what 23 times 24 is, 09, 12, which we get to leave like that. We're not going to turn it into base 10. So we can multiply anything by 23 using this technique. And just for oh, I don't have a practice question. Okay, why don't I make one up so that we can just practice this skill? So why don't you go ahead and do 23 times 45 also, just to practice. So that one you could type the answer into the chat. Oh yes, the times table, one way to get to it is in the Google Classroom. So if you're not signed up for the Google Classroom, here's a link for you. I'm going to send this link out, everyone in meeting. Okay, that's how you could sign up if you're not already a member of the Google Classroom. And in the Google Classroom, you will see for today's lesson some links. Oh, I see. So are there how many? 1, 2, 3. Oh, I see. People haven't logged into the Google Classroom. So definitely register yourself for the Google Classroom, because that's where like the homework assignment is and everything. Okay, good. I see the answers are coming up in the Google chat, and the answer is 1715. What is that in base 10? I don't know. It doesn't matter. The question was, what is 23 times 45? And the answer in base 60, so we're able to do that. So now before I get into so this would be a pretty annoying method, because you would need to have a tablet for every, you'd have to have 59 of these tablets, one for each number. And the people whose job it was to be able to multiply, they would have all 59 tablets, so it wouldn't be a problem for them. But for an average person, they don't want to have 59 tablets. So there's going to be another method for multiplying that does not require 59 tablets. But before I can show you that method, I need to tell you a little bit about division. Now, division, they didn't actually have real division. They would actually divide by multiplying by the reciprocal for the most part. So they would have to have this chart with, like, remember 1/5 was 12/60ths? They would have reciprocals. Remember 1/18 was, by the way, in some books, instead of saying 0320, they would put commas in between, just like different translators have different ways. I like to say put 2 digits for each digit, but see, it says 3,20. So they would do the semicolon and they would put commas between the digits, but I like to use the 2 digits with the space. So division was pretty hard because they would do it by multiplying by reciprocal. But we're not going to need to do that method because there's 2 divisions that are a little bit easier. And they are dividing by 2 and dividing by 4. So first of all, Dividing by 2 is pretty easy. You just divide each place by 2. But sometimes we run into a complication. And that is, well, you could do number 11 quick because that one, both of the numbers are even. So everyone go ahead and divide 1230 divided by 2. This is question 11. Okay, let's have more people writing their answer. I see, yes, 1, 2, 3. Good. Okay, so 1230 divided by 2 is 0615. But what if it was 1130 divided by 2? This is question 12. That's complicated because the 11 is an odd number. So I have a sneaky trick for you on this, and it is to change the 11 into a 10 and change the 30 into a 90. It's almost like borrowing, but it actually is borrowing. It's exactly what you would do if you were subtracting 1130 minus something where the units was bigger than 30. And then we can do it. I'm not saying that's how they did it. I think they just had a good intuitive feel for 1130 divided by 2 was like 5.5. I shouldn't say how they did it. This is how I like to do it. Another thing that's useful is dividing by 4. You'll see why I'm only picking these two right now, dividing by 2 and dividing by 4. Why doesn't everyone go to question number 13 and do what do you think happens when you divide by 4?
Six, 10.
That's right. In the case where both numbers are divisible by 4, we can just do that. But what if, and I think I have 3 more questions, 1340, 1440, 1540. Let me write this down in one spot. 13, 14, 15. Okay, what about these 3 questions? 1340 divided by 4, 1440 divided by 4, and 1540 divided by 4. Now the last digit I'm purposely making divisible by 4, but in all 3 of these cases, the first digit is not divisible by 4. Why don't you take 5 minutes to ponder how do you think you do these 3? I'll give you time to think about that. And those are the next 3 questions on the Desmos. Okay, by the way, I just put a link to the homework document. It's not due until a week from today. Oh, someone asked about 23. No, I just gave one table with the 23, so we could do 23 times this and 23 times that. But if I were to ask a different question, you would need a totally different table. So all my homework questions are 23 times this and 23 times that.
So to submit, do we just download it and then upload it as a document, right? With the answers?
Yeah, yeah, you can scan it and just submit it to the Google Classroom. So if until you get into the Google Classroom, I suppose you could email me the homework answers. So for 1340, the sneaky trick is to change the 13 to a 12. It is okay if it's handwritten, and change the 40 into 100. And now divide them both by 4. Now for 14, I'm going to still change it to a 12 because basically I want it to be divisible by 4. But then I'm going to change the 40 into a 160 because I took 2 60s away from the 14, so I'm adding 2 60s, and then I can divide. See, if this number is already divisible by 4, adding on a bunch of 60s, which themselves are all divisible by 4, won't change that it's divisible by 4. And in this one, again, I'm going to change this to a 12. I want this first number to be divisible by 4, but I just took 3 60s away, so I'm going to add 180 and then divide by 4. 220 divided by 4 is 55, yeah.
That's 03.
03 then. Now, this isn't what they would specifically do, but I'm kind of mixing a little bit of modern because now we get to the final thing for today. And today is a good example. Every class, just so you know, it's like this difficult. This is the difficulty level. It gets a little bit harder, but not that much harder. Like, this is hard. It's confusing with all these, algorithms and things that we're doing. But this is also a good amount of material, like the amount, of course, there's only 15 classes to cover an entire course. So, but now I have the final thing for today. There is another way to multiply that would not require having so many tables. And I'm going to do the question 26 times 14. Now, I don't have a 26 times table or a 14 times table, but instead, I have a new chart. And that chart is here. Let me give you I just gave you the link to the link to this document. So you see this chart here? This chart it says the table of squares. And I'll explain what this is and how it works. Table of squares is a nice way to multiply any two things together as long as they, well, you could add anything together with it, but for our purposes, I don't have a full table of squares. See what this is? I have the numbers 1 to 50. I really should have gone up to 59, but I only went up to 50. And what this is the square. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. When you get to 8, 8 squared is 64. But 64 in base 60 is 0104, 60 plus 4. 9 squared is 81, which is 60 plus 21, which is 0121. And they made up the table of squares for all the numbers. Here I give from 1 to 50. I should have gone from 1 to 59, but I didn't. Let me show you how you can use the table of squares to multiply 26 times 14, and then it will become an algorithm. So this is really fun, this one. You'll take a look. Here is the method. Step 1. Add together 26 plus 14 and look up the square on the table of squares. So 26 plus 14 is 40. And on the table of squares, 40 squared is 2640. That's their way of saying 1,600. Step 2. Take the bigger number minus the smaller number and look up that answer, square that, and look it up on the table of squares. 12 squared is 144, but in their world, 12 squared is, wait, is it not on the chart? No, there it is. 224, 0224. Step 3, subtract these two things. And step 4 is divide the answer by 4. And that is 246 times. That's 364, which is also what 26 times 14 is. So it worked. Let me just make sure. 26 times 14. Yes, 364. So yes, it worked. I'm going to go like this in the notes. Equals 364. And this also equals 364. So it worked. So now I have a challenge for you. And I want you to spend this is such a good question. I really want to put you in little groups for it to talk about it, because this is the perfect question to ask the 5 words that we dread. Why does, it's only 4 words, this work? Why does this work? Why, if I add the numbers and square it, and then subtract the numbers and square it, and subtract the 2 answers, and then divide by 4, I get the right answer? Why does that work? I am going to attempt to put you into breakout rooms for this. Let's see. Breakout rooms. Assign automatically. I don't want 8 participants per room. Oh, I see. Create 1, 2, 3. Okay, I'm going to make 3 breakout rooms with 3 people per room. And you're going to discuss for 8 minutes. Why does this algorithm work? So go into your rooms now. And I know I've been in Zoom rooms. I'm in this program called Math for America for the math teachers who win this award. They're supposed to be the best math teachers in the state and city and all. And they put us into breakout rooms, and I'm one of the only people who's really giving the breakout room my best shot. And a lot of people just say, oh, breakout room, I'm just gonna tune out. But please don't do that. This is a really fun question to talk to with 2 or 3, with 1 or 2 other people. So I'm going to bring you guys back in 8 minutes. Discuss why does this work? And here you go. Open all rooms. you can do question 17 on the Google Classroom where you get to type in, why does this method work? Question 17 on the Google Classroom, not on the Desmos, you could type in your answer, why does this work? And then you could do question 18 where you do the process for it. Okay, everybody, welcome back. I saw one really nicely written up explanation. You know what this will remind you of in the algebra regions? They would say this sometimes, prove or show, verify that this is an identity. That's how they say it. They say it that way sometimes, verify that this is an identity, that if you add something and square it and subtract you add two things, square it, subtract the same two things, square it, subtract the answer and divide by 4. Well, depending on what grade you're teaching, you may or may not be familiar. So let me just, remind you. Then you multiply x plus y times x plus y. You don't get x squared plus y squared, contrary to popular belief by many students in algebra. But instead, we do they still call it FOIL? They should. If they don't, you could type into
Yes.
this. Oh, good. X squared plus xy plus xy plus y squared. I always like this picture to describe this algebraic fact. If you make a square that's x by y, each side is x plus y, you get x squared plus y squared, plus you get these two extra rectangles. I like that. They call it the area model sometimes. And I've seen in recent years, they even teach, multiplication by doing that. Oh, the class ends at 12:30. So if x plus y squared is x squared plus 2xy plus y squared, and x minus y squared, oh, it says 12? Well, I was under the impression that it was 12:30, but if do other people is the idea it's just 2.5 hours, it's not 3 hours? That's great for me.
Yeah, it says 9:30 to 12, yeah.
Okay, great. So in that case, I am going to finish up.
I have a question because I did it the second way.
I didn't
Yeah.
teach that one yet. The second way, the other way with the what do you mean by the second way?
The second way with the different steps.
Meaning,
The first
Do you-
way that you showed us. Yeah, that.
do you mean with the with the chart, like the 26, 26 times 10? The problem is we don't have a 26 times tables in base 60. So the only one you'd be able to do is 23.
Oh, okay. Because I'm like, I'm using a chart and I got a different answer. Okay, never
Yeah,
mind.
that chart's for 23.
Okay,
So
thank you.
now, if you subtract these two things, and you're careful about your removing of the parentheses, plus 2xy plus y squared, you end up with 4xy, which of course, if you divide by 4, you get xy. So because I didn't realize that the class was over, I'm not going to I'm going to change the last homework question I have one more method based on the table of squares, but I'm going to make it a question instead of teaching it to you. So that's fine. I'm going to post this video. It usually takes like an hour or something. I'll post this video by tonight. I'll also post the notes by tonight. Homework's not due until next Monday. I'll see everyone tomorrow at 9:30. And I'll stick around for a second while if someone has some questions for me. But then everyone else can log out if they want.
Thank you.
So the homework that's there now, you're modifying.
I'm gonna change one question, yeah.
Okay, thank you. See you tomorrow.
Okay, see you tomorrow.
So, Professor, I'm the one who kind of missed class.
Yes.
So are we meeting on Zoom?
Yes, so except for, so this week it's all Zoom.
Okay.
But the other 3 weeks, I'm gonna have people come in on Thursday. So basically,
Okay.
we only come in 3 times.
Okay.
The next, not this Thursday, but the next 3 Thursdays, and the last Thursday is the final. So we just come in for two actual classes.
Okay. All
So
right,
I'm
great. Thank you.
sorry about that confusion. I sent out the
No
email.
worries.
Maybe it went to spam or something, or maybe I had.
No, I think what might have happened is that I transferred schools and it was another CUNY school. So maybe my default is still my old school email instead of City College. That might have been what happened, but it happened to someone else too. So I don't know what happened for her.
Yeah,
But
I sent you guys some emails just now, and we'll get it straightened out. So I'm glad
Okay.
that you're able to come in. But I'll put up the video. The what we started with was fairly straightforward, with the base 60. So if you're gonna miss any days, that was, I've
the
definitely
best one to
started.
miss. Okay.
Yes. Okay.
All
See you
right.
tomorrow.
Thank you.
You're welcome. Bye.
Professor, the homework is the first grade for this course, right?
Grade? Yes, that's right. I mean, there's a homework, and I'm also kind of informally just making sure that people are answering questions on the Desmos
Or like participation?
participation. Yeah, but
Okay, sounds good.
so as long as you're generally typing stuff in those boxes, there was one person who like disappeared for for a half hour. So, but technically the first grade is, I guess, the participation, and then the homework's going to be the second grade.
All right, cool. Thank you so much. Have a
Okay,
good
you're
day.
welcome.